Alrighty, I feel like I've got a bit of a tough act to follow. Aaron Frost and Jameson did a great job this morning. And I really appreciate everything that they talked about. And I fully agree. I actually had a long conversation with Aaron that lasted probably like almost 2 hours last night. And we came to terms, and it was great. I loved it. But so to start off with this a little bit, again, Bret Little, Canopy Tax. If you have questions after this, I'm going to fly through this really fast. I got a lot to cover. But please message me, find me somewhere afterwards, and I'd love to talk to you about it. Monolith versus microservices, this pendulum that Jameson has described. And I feel like just even starting the conversation here, sometimes developers use like monolith as like a derogatory term. Like it's derogatory. Oh, you're building a monolith. That's horrible. It's a dirty thing. And in reality, there are pros and cons to both approaches. And if you go with microservices, there are going to be some cons. There are going to be some pros, but vice versa. So it really is a pendulum. And I really like Jameson's talk for emphasizing that. I also really want to emphasize there's a really great talk. Jameson, or it's actually a paper. Jameson mentioned we can learn a lot from the past. Frederick Brooks wrote this paper in 1986. If you read this, it's amazingly current for what we're dealing with today and right now. And not just software development, but like product development, UX design's mentioned in here, all the things. And it's actually very good. And the emphasis and the point is there is no silver bullet to building software. Why? Because it is hard. And there's two different types of hardness or complexity. There's hardness of essence and hardness of accidents. We can improve the stuff that is accidentally hard, like languages are hard, or development environments are hard. Things like that are hard. But some things in their essence are just hard. And software development is hard. And there's a lot of reasons why it is hard. But speaking of that, to go into depth about monolith versus microservices, I think we need to have a conversation of what challenges are we facing right now in the JavaScript world. Because I feel like we do some things really well, other things we have a lot of room for improvement. We can take what we have, what can we innovate and change? And like what I'm going to suggest and what I'm going to talk about, by no means I intend to be like the end-all be-all. Again, there is no silver bullet. But I want to get the community talking about and thinking about some of these problems that have not been addressed in the browser. With that, what challenges do we face in developing front-end applications? What do you guys think? What challenges do we face?
Third-party fatigue.
Third-party fatigue. That's definitely one. I definitely feel that. Frankenstein?
I think a fun one is that people think it's easy.
It's easy?
Inherently, web is the front end is an afterthought.
Yeah.
It's easy. It's just JavaScript.
Exactly. It's just JavaScript. So one issue I know I've seen, and this I can emphasize this issue in a story. So I worked at HireVue a little while ago, and at HireVue is a great place. But our CTO at HireVue, I remember, so we'd get together with these engineering meetings, these architectural discussions, and our CTO, Lauren, he brought up multiple times, he's like, guys, why are we so slow? We used to be so fast. We were like so awesome. Like we were young, we were small, we were a startup. We could build things quickly, but now we're slow. Why are we slow? How can we fix this? That's a great question. I don't know. How do we fix that? You start small, you can build things quickly, but all of a sudden you start crashing and burning. Another problem. This is an interesting one. Pandora. Who here uses Pandora or has used Pandora? Pandora is really cool because like in 2010, they were extremely innovative. And they were like one of the first big companies to use a single page application framework for their core product. Like Backbone.js was like the thing. It was like awesome, and Pandora built their whole experience on Backbone. So if you go load up Pandora right now and you view the source of Pandora and kind of hack around, my wife hates it when I do that, when we're like hopping on a Netflix and I pull up the source or whatever. But if you pull it up on Pandora, they are currently on version 0.5.1, which was published in 2011. So now imagine you being the developer who has to deal with that. Like say you're tasked to add a feature to it, or you're supposed to change it. You're in an interesting situation. That is 5 years old. The API has drastically changed from Backbone, and all of the information on Stack Overflow is not current, or your version of the framework is not current. You're in a really crappy situation. So if you're going to substantially change Pandora, what are your chances? Your chances are you're going to need to potentially rewrite the thing. Granted, Pandora isn't that crazy of a UX. Rewriting it maybe isn't that big of a deal. But I bring up the question for you because all of us are in a situation right now. Angular 2 is just released. React is pushing out new releases. Some of us are using Angular 1. Some of us might be using Backbone. Some of us are using Ember. Some of us are using our own Frankenstein framework. But the point is, if you ask your product manager, your company, to rewrite your whole application to Angular 2 because it's awesome and I love it, or React because it's awesome and I love it, that's like the worst thing that you can ask your product, the worst thing in the world, to rewrite everything from scratch. So I ask you guys right now, and I want to be very candid, what are you doing right now to mitigate against that? And I don't think we do a very good job in the JavaScript community to mitigate against it. We just essentially say, OK, I want to write in React, so I'm going to write in React. I'm going to throw everything else out, and somehow we're going to rewrite it. That sucks. Like, how do we mitigate against the inevitable rewrite that it seems like it's always, it's going to happen? And how do we put our company in a better situation than Pandora is in right now? Because Pandora is in a crappy situation. So Smith's theorem says, this is another challenge. Smith's theorem says that scaling an app to handle lots of data is an order of magnitude easier than scaling an app to handle lots of features and developers. I have personally found this to be true, Smith's theorem and Dave's corollary. Very few developers have to solve data scale problems, but almost all developers have to solve feature and team scale problems. And this directly relates to what I talked about at the very beginning. You start out developing quick when you're small, but as you develop features, the scale of your feature increase is not linear with the amount of complexity that your application starts to become. So how do we solve that? So these are all the questions I'm trying to figure out, like, in building front-end applications, because I don't feel like we do a very good job solving all these things. And we're all trying. Angular 2 has a lot of great things, a lot of things that are coming out. But how can we do a better job? One way people solve these problems is by process. It's like if you get a huge application, you have 100 developers contributing to it, well, we can add lots of process to it. You can't commit or you can't push until this person looks at this, and then we follow this review process, blah, blah, blah. It gets crazy. But even when you add this kind of process, you still seems like you have this inevitable problem of, I touch the code here, I break it there. And there's nothing that, like it sucks. And like we all deal with this on a daily basis if you have any kind of application of scale. So I've led up to this as the reason SOA, microservices, this whole pendulum thing kind of was introduced years ago. Again, not necessarily as a silver bullet, but these are the things that they're trying to solve with this way of building software. But it's interesting because I feel like we've figured it, or like people have kind of defined these patterns, service-oriented architecture for backend. I don't feel like anybody has done it effectively front-end. And that's specifically what I want to focus on and show to you guys. So to start off, what is a service? Like, this is crazy. It's like this technical definition. It's a bounded, loosely coupled, and cohesive piece of functionality. Oh, OK, whatever. What the heck does that really mean? Well, I'm just going to try to define it in a very simple term. A service is, if you think about a service, it's easy to think about if you think about like a backend service. You have a backend API that's isolated. It probably has its own data store. It's entirely isolated. You can deploy it. and everybody automatically can point to that new API, and it's there. It's deployed, and you don't need to do anything on your own to get those changes of the API. A key part of a service is a service needs to be able to change independently of each other and to be deployed by themselves without requiring a consumer to change. And this is an important part of a service, a very important part of the service. And you might ask yourself, well, in the front-end community in JavaScript, we have NPM. We have NPM packages. We have lots of modules. That's great. Well, is an NPM package a service? Well, not really. An NPM package is kind of like a shared DLL sort of library in your application. Why is that? Because if I have a new version of a package, I have to go to that code, that repository, wherever it's at. I have to change it. I have to build it, update the version. I have to publish it to NPM. Now I got to go to every one of the consumers, do an NPM install, the latest one, then rebuild that one, then build it, then publish it, and then subsequently go to all the different dependencies. And what's the problem with that? Well, that's great until you get lots and lots and lots of dependencies. So say you have component 1, component 2, maybe app 1, and maybe app 2. They all depend upon these separate NPM packages that might be on all different versions. We have shared library B that has 1.5 and 2.5. As time goes, your company gets bigger. Some people are on different versions of this shared library. All of a sudden, you have a bug in, say, shared library B in all the versions of it. And now I need to quickly fix this because it's a major bug that we didn't know about. And this is a simple graph. Now imagine this graph being much bigger. I have to go update shared library B. I have to update like multiple versions of it, publish them, and then try to update everything else that depends upon it and rebuild everything and redeploy. And like this can be really, really, really crappy. So how do we if NPM packages don't really allow us to do microservices in the browser, what could we do to do microservices in the browser? There's something called System.js. Who here's heard of System.js? Okay, like when you hear of System.js, most people immediately think there's like System.js, but I like Webpack. System.js and Webpack, they're like different, right? Or they're like competitors. But in actuality, they're not the same thing, not at all. They're not competitors. They're very, very different technologies. System.js, so this is, Sean Larkin is one of the core, he's on the core team of Webpack. And this is a discussion we got on Twitter with him, specifically about some issues we were trying to do with Webpack. And a core key thing to remember about Webpack is not a module loader. Webpack doesn't do dynamic things. Webpack is a bundler. It is a freaking awesome bundler. It's like the best bundler we have. Like, it's amazing. But at the same point, it is not a module loader. But why would I want a module loader? So System.js is a module loader. And I want to tell you what a module loader means. So a module loader, you all probably recognize the syntax. This is ES6, a module. I want to import this module from this path. Well, for actually you to implement this code in the browser right now, no browser can implement this. Because it's not even, like, sure, we have spec the syntax, but we don't have spec what that syntax means. Nobody can agree on how to actually load that path. So no browser can even implement this at this point. But in theory, they're coming to an agreement on that. And System.js is an attempt to implement that specification of loading that module. So this when I say it's synchronously loading code, my module.doSomething will not execute until that dependency is resolved and its dependencies are resolved, everything is resolved and downloaded. Whereas asynchronously loading code, this is specification. In theory, it's probably going to change slightly, but the point is this will be in the browser at some point, where you can dynamically import some code, get a promise that gives you the module returned, and then you can do something with that module. Really, both of these things are exactly the same functionality. One's except it's doing asynchronously versus synchronously. But what is really cool about the new module specification, which is you can dynamically register things into that registry. I can programmatically register something into the module, the actual registry. I can dynamically put something in there. And then when I import that, because it's already in the registry, I'm never going to make a network request. And then I can programmatically remove it from the registry as well. And that's freaking awesome. That's freaking awesome because like you can, in theory, with the new specification, do dynamic module unloading and loading, like hot module reloading. Like, that's awesome. That's really cool. And so, like, rather than like, and I'm not trying to diss on Webpack. Webpack is awesome. Webpack is a bundler. Bundlers that do system.js stuff, the whole bundle, all it is a ton of system.register calls. Like maybe 1,000 system.registers in a big old fat bundle. And then finally, you have a system import at the bottom that goes to an entry point. And then it never needs to download any code because everything's already registered into the browser. So this is system.js. System.js allows us, it's an implementation of what the new spec will be, hopefully, if everyone agrees upon it at some point in time. But how can this help us solve this problem to actually do microservices in the browser? So what if, at runtime, if I just had a module name, and with that module name, I could dynamically resolve it to an actual URL at runtime? So if I did that, then whenever I required this module, I never needed to know anything about it. Like somebody could deploy a new version of it. I don't care when or how they deployed a new version of it. I just get the new version. I don't need to worry about anything. They can be entirely independent, deploying whatever the heck they want as long as they maintain an API. Like, that's awesome. So that's what I want to talk to you about today is a system.js plugin that does exactly that. And this is how it works. Some module, exclamation point, Sophie. And the interesting thing about this, again, is my code doesn't need to know anything about how that code is deployed, where it's located. I just get it. So I can have a team that can be entirely in charge of that. They can make it awesome. They can make it do whatever they want with it. And I get those changes. And this also works with synchronously loading it as well. So the way this works is in system.js, you can configure system.js with whatever you want inside of it. And there's a couple ways that the resolution happens. Essentially, we need to resolve this module to a fully qualified URL. And you can do it statically like this inside your code, or it can be dynamically done with a URL at runtime where we can get a manifest of where all the services are located. So I just want to do, how much time do we have? OK. I'm going to skip this demo. And I am just going to go here. So this is an example of our application as you see it. So and this application actually has 8 or 9 different services running at any point in time. There's a service which is the primary navigation bar at the top. There's a service for the content in the right. And there's a service on the left for the navigation bar. And some of the interesting things that can come out of this, one particular thing is if I'm system importing a service, and at runtime I'm resolving the location of that service, I can very easily intercept that resolution. And what do I mean by intercept that resolution? Let me show you our application live in production, if internet works, if the internet gods are happy with me today. OK, so our production application, here it is. Absolutely exciting, wonderful. Well, like I said, a couple of these things are services inside here. Well, what if I'm on production. What if I want to start changing stuff on production right now? What should I change? I don't know. Let me pull something up. Let me pull out some code here. Okay, so I've pulled up the code for that primary navigation bar at the top. So I'm going to go to a style file inside here. So this is the normal color, just a nice little green color here, but let's change it to orange. Why not? Change it to orange, and I'm just locally writing this code. I built the nav bar. It's building right down here. I've got a watcher, and I've actually got a web server over here running on port 5555. I'm just hosting out that JavaScript file. So if I come over here and I go HTTPS, maybe. There it is. Okay, that's just some code for this thing. So it's there. So if I come over here, I'm going to, in production, I'm going to say local storage dot set item Sophie primary nav bar, and it's actually on port 555. Now I'm going to refresh the page over here. And so rather than pointing to production, I'm pointing to my locally hosted version of the primary nav bar. And I can do whatever the crap I want with it. But again, this is only on my machine. But in production, I can do all sorts of stuff. Like, so maybe, how about we have an Angular app on the right here. So let's come inside that Angular app. We'll start a web server on port 444. This is an Angular app. Let's just come into the Angular. Let's say we have so we have our client dashboard template, which is just this template right here. It's on the right. We see in there. Let me just come inside here, and I'm going to copy that whole code block. I'm going to paste it. I'm going to say, hello, UtahJS, everyone. I'm going to change this reference. This is a link right here. Let's make a new link to test, maybe? Yeah. Just a new route, and we'll say, click me. We'll delete that crap in there. And now, we're going to define a new route in production. We're going to call it state. This is UI router in here. We'll call it test. And we'll just say template. Okay. Okay, let's hope that all that worked. Now I'm going to refresh over here on the left. And we've built a little inspector tool to inspect which services are overridden. I'm just going to come in here and I'm going to say workflow. Just for time's sake, I'll refresh. Now right in here, I say, hello, UtahJS, everyone. And click me, go to a new route in production. So just to finish off real quick, there are definitely downsides to services, microservices, and I wanted to mention them real quick. Because these things they're not versioned, you have to worry about backwards compatibility. You don't just make backwards compatible changes to your API, just like you would with a backend API. You have to have a planned release to do such a thing. There's potentially complex server management. There's more DevOps when you have lots of servers involved, and there's inter-service communication. You have to solve that problem. But overall, I would love to talk to everyone about these sort of things and, I don't know, like how we can do SOA or microservices in the browser. And thank you.